Sensor-Based Aquaponic Fish Pond Dataset. So I'm going to look at the development of the data set, the data collection process, and how the data is being used. Regarding the development, we had 12 aquaponic catfish ponds. By aquaponics, we mean it's a combination of a hydroponic and aquaculture. So as you can see on the picture there, we built artificial ponds made of tarpaulin and then plant bed on top of it, but it's soilless. We just have a charcoal and gravel. So we have a pump, submersible pump in the pond that reticulates the water, pumps the water into the plant bed. And with the nutrients coming from the pond, the plant grows. In this case, we have, this is cucumber. Some other time we did spinach. So we had, we also worked with 2 farmers we set up similar ponds in their sites as well as on the campus. And then one of the sites was a control, while the other was a combination of aquaponics and just aquaculture. And we used 1,000 fingerlings. So we grew them for about 9 months. And during the process, we were collecting the data. Now, the IoT component was built using ESP32 microcontroller, and we used 6 sensors. 2 of them were submersible. 4 of them were submersible sensors: the turbidity sensor, temperature, pH, and the dissolved oxygen. And then we used 2 gas sensors, ammonia and nitrate, which we hung above the water. So it reads the water level, the ammonia concentration and the nitrate, because these parameters are very important. If you have excess ammonia, your fishes will die. And so while the nitrate also takes nutrients from the water and feeds to the plant to grow the plant. Then, this data set was collected in real time. It was uploaded to the cloud. The purpose of this is that a farmer does not need to be physically present in his farm to see what is going on inside the water. So he can monitor the water temperature. If we take it a little further, we may want to introduce some control to do automatic water change or topping of the water, depending on the values you are receiving from what you are seeing from the cloud. Okay. So by the end of the data collection, we cleaned the data, annotated them. We had the data annotators who also went to the farmers. They had also handheld devices with which they compared the census reading to be sure that they are at par. So after that, we got over 2 million data sets, and we uploaded it to Kaggle. And this data set, as at present, it has gotten over 164,000 views and 772,000 downloads. That's 1,772,000 downloads so far. And then we're going to look at, so when we publish this also, we have had over 21 citations on the publication, because we published it in Data in Brief, and to let people know about the data set. And because of that, we've gotten a lot of citations, and we've seen what people are using it to do. Here I have selected just a few use cases, what other researchers are doing with our data set. The first one there is a temporal fusion transformer-based prediction in aquaponics. The second one is smart water quality prediction using atom search optimization with fuzzy deep convolutional network. And then the fourth one got me interested because, incidentally, I was made a reviewer. The article was sent to me to review, and I discovered they made use of our data set. And this is the comment they made, which I quoted here. They said, these data sets were meticulously generated at a rapid 5-second intervals, capturing the real-time evolution of water quality parameters and the living conditions of the resident fish population. So these authors were from Qatar, and I discovered they got a government funding to develop this model, which they called an innovative machine learning framework for fish farming optimization. The article has gone to the second round of review, and I think it's going to get accepted. And I think they did a very beautiful job with our data set. So maybe you may look out for this article, because they did a great job with the data set. And then for us, we also did machine learning modeling with the data set. And this is from one of the ponds, and this is the kind of result we got. And then we also did for all the ponds. The table is small, the one on the left. We did for all the ponds, and we got good values. The purpose of this is for the farmer to be able to predict the yield prediction. So we went forth to develop a mobile app with the model that we have developed. So what you are seeing here is a screenshot of the mobile app with all those parameters. So a farmer could take, for instance, you could have a, what do you call it, maybe a temperature sensor, picks the value and puts into these boxes and predict what the fish growth will look like in terms of weight and length of the fish. These were the two parameters that we are looking for, because in the end, what matters is the weight of the fish. So this app, we're still working on it. We are working on a time series version of this to improve on the prediction. And moving forward, we're also looking at computer vision part of it, which we want to capture images to use to classify these fishes based on size, weight, and all that, so that once you get an image, the computer will tell you the weight, the size, and the length of it, and tell you the species. These are the things that we have, we are doing currently. All right, so this is our team, and thank you for your attention.